Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about section of solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now the today's discussion is about the solid which has been cut by a section plane which is perpendicular to the horizontal plane and inclined to the vertical plane. So here we can see that we have got a cutting plane, and this cutting plane happens to be perpendicular to the horizontal plane and it is inclined with respect to the vertical plane at an angle phi. So such cutting planes, they are called auxiliary vertical planes. Now you can see, if we have a solid available with us and it is cut by an auxiliary vertical plane, so the vertical plane projection will be drawn below the xy line. That is, this cutting plane will be cutting the solid below the xy vertical line, and once we cut this solid over here, now this portion of this original solid will be discarded and it will be thrown away. Now we are left with this remaining portion of the solid. Now whatever projections of this remaining cut portion of the solid is available with us, and whatever projections of this particular solid will be drawn onto the vertical plane in the front view, so we will not be getting the true shape of this particular cut section in the front view. So whatever sectioned view will be available in the front view, this will be the apparent shape of this cut solid. Why this is going to happen? Because our cutting plane happens to be inclined to the vertical plane at a given angle phi. So since this cut section is available at an angle phi with respect to the vertical plane, so its projection, that is the projection of the cut section which are available onto the vertical plane, that is in the front view, will provide us the apparent projections of the solid or the apparent projections of the cut section. So then if we have to obtain the true shape of the cut section, so we need to draw another auxiliary vertical plane which will be parallel to the original cutting plane or this cut section, and the projections of this cut section onto the new auxiliary vertical plane. So these auxiliary projections, they will be called auxiliary elevation projections over there. So into the auxiliary elevation onto the new AVP which will be drawn parallel to the original cutting plane, we are going to obtain the true shape of this cut section. So this is the procedure which will be followed. Now here we have a cone available with us, and this cone is being cut by a cutting plane which is inclined to the vertical plane, and this happens to be parallel to the vertical plane as well over there. So this will be perpendicular to the horizontal plane. So this cone, since it is being cut in the top view over there, so this is the remainder portion of the solid or the cone which will be left available with us. And whenever a cone is cut parallel to the axis of the cone over there, so the true shape of the cut section which will be available with us, this will be rectangular hyperbola. And this is what we have already discussed in the first lecture on the sections of the solid. So these are all the conic sections, right? So now this is the case. So here we can see that this cutting plane happens to be inclined to the vertical plane, and the angle of inclination is given to us as 60 degree over there. And since this cutting plane happens to be perpendicular to HP, so this cutting plane will be parallel to the axis of this particular cone. And now in this case you can see that we should divide the top, you see, view of the base of this cone into 12 equal parts, because more number of points should be available, because in this case the cutting plane is not cutting all the artificial generators of the cone. So only the few generators plus couple of base edges will be cut over there. You see, these are the couple of base edges which will be cut by this cutting plane, and only few generators which will be lying in this area. So they will be cut by the cutting plane. So if we are going to divide our base of the cone, that is the circle over here, only in 8 parts. So very few points will be available over here. So since we have cut this base into 12 equal parts, that is we have divided this into 12 equal parts, so reasonably good number of points, that is 6 number of points they are available. So out of these 6, 2 are lying on the outer base over there, that is outer boundary of the base, and remaining 4 points they are lying on the generator. So we have divided it into 12 parts, but the 8 generators, they have not been cut by this cutting plane. So only the 4 generators which are lying on this side, they have been cut by this cutting plane. So the total points of intersection in this case we have obtained as 6. Now since this cutting plane is cutting this cone at an angle of 60 degree to the vertical plane, so whatever front view which we are going to obtain in this case, this front view will be the shortened front view. So this view will give us only the apparent shape of this cut section over there, that is this rectangular hyperbola is there. So we are not going to get a perfect rectangular hyperbola, it will be a smaller shape of this rectangular hyperbola which we are going to obtain. And in this case, in the top view, the edge view of this particular cut section will be seen, and since this edge view is available in this top view, so we need to draw another auxiliary plane, which is auxiliary vertical plane, which will be parallel to this cutting plane, which is original cutting plane. And since this edge view of the cut section, it is parallel to the new AVP, that is x1 y1 we have drawn. So whatever auxiliary elevation, you see projections will be obtained onto this AVP. These auxiliary elevation projections, they are going to provide us with the true shape of the cut section, and we can see this true shape is of the greater size as compared to this particular front view, that is the section front view which we had obtained, right? So this was the basic discussion. Now let us start with the construction part. Now let us read out the statement. So we have a right cone having the base diameter 60 millimeter, axis height is 70 millimeter, it is resting on its base on HP. Since the cone is resting with its base on HP, so in the top view, the true shape of the base of this cone, that is the circle, will be drawn. So this will be drawn in the top view over there, and this will be drawn below the XY reference line. Second, there is a sectional plane which is perpendicular to HP and inclined at an angle of 45 degree to the vertical plane. It cuts the cone at an angle of at a distance of 10 millimeter away from the axis, and we are required to draw the top view, sectional front view, and the true shape of the section over there. So just see here we have the XY line. Now we are going to draw the top view of the base of the cone, so which happens to be a circle, because now this cone is going to be cut by an AVP, and this AVP is not passing through majority of the generator, so we need to divide this into 12 equal parts, so that as many points as possible they should be available onto the top view as well as onto the front view, that is large number of POIs should be available over here. Now 1 to 12 we have labeled the number of the sectors that we have obtained, so the size of each sector is equal to 30 degree, right? So this is the phi means that is the diameter of the cone over there. Now here you see, once we draw this particular top view and we have divided this into 12 equal parts, we have been able to locate the axis of the cone. So O point corresponds to the apex and O1 corresponds to the base axis point. So O point is corresponding to this apex, axis point at the apex, and O1 is the axis point at the base. So now height of the cone is given to us as 70 millimeter. So this is the 70 millimeter, this is the axis height. So we locate this point O dash over here. So having located this point O dash, now I can join O dash with all the front view projections of the base which are obtained on the base. And since all the points of the base, they are resting onto the ground. The cone is resting with its base on ground. So the front view of all these points, it will be available on the XY reference line. So all these 12 points, they are available in the horizontal plane. Now having joined all these generators, now this is my axis top point O dash. This is my axis bottom point, that is at the base O1 dash. Now we are given that there is an AVP, that is a sectional plane, which is perpendicular to HP and it is inclined to VP at an angle of 45 degree. It cuts the cone at a distance of 10 millimeter away from the axis. Now from here, just see, from here I will be drawing a circle or a semicircle such that the radius of this semicircle should be 10 millimeter. Just see, I have drawn a semicircle over here so that my cutting plane should be tangent to this particular sector of the arc over here. So the radius of this arc is equal to 10 millimeter. So from here I am going to pick up my cutting plane. This is my cutting plane. So this cutting plane is drawn at an angle of 45 degree with respect to the vertical plane. So this is the angle of inclination of the cutting plane is 45 degree with respect to the vertical plane. So this angle of inclination is 45 degree, and this cutting plane should be tangent to this arc that we have drawn at a radius of 10 millimeter. So the cutting point will be 10 mm from the center of the axis over there. Now having drawn this particular cutting plane, which is an AVP, now let us work out how many POIs we have been able to obtain. So two POIs are there, you see, on the base. So cutting plane is going to cut the base circle at this particular sector between 7 and 8 at this point. Similarly, the cutting plane is cutting the base circle between this sector point 3 and 4. So another POI is located. Then you see, this is the cutting plane. It is going to cut one generator over there, which is O7. Another generator O6 will also be cut by this particular cutting plane. Third generator O5, it has also been cut by this cutting plane at this point. And finally, this is the fourth generator O4, which has been cut by the cutting plane at this point. So in all 6 POIs, they have been located over here. Just see, there are 6 POIs which we have been able to identify. And having identified the 6 POIs, now we are going to do the numbering of all these POIs and transfer each POI in the front view. Because POIs, they have been located in the top view, only thing is the numbering is left. So we can start from one side. So the first point, which is lying on the base circle between the sectors 7 to 8. So into this sector 7 to 8, cutting plane is intersecting the base over here. So this first point, which is found lying onto the base, just see, it is this point lying on the base of the cone over there. And this point name I am going to name as small a. So just see, small a, it is the name of the point which is obtained between the sectors 7 and 8, which is lying on the base. Now I will be taking it upwards. And now you see, where does 7 dash lie? 7 dash lies on the XY line. 8 dash lies on the XY line. So the front view of this sector 7 to 8, it lies onto the XY line because it lies on the base. So I have to take a projector from this point A. You see, blue lines I am going to use for all these POIs. So in order to distinguish between original projectors and the projectors of the POI, I am going to use the sky blue line over here. So please check, from point A, I am going to draw a vertical projector till it meets the front view of this sector 7, 8, which is 7 dash 8 dash. So this is the length of this particular sector in the front view. So this point A top view is here. The front view will be located on the XY reference line. So I have named this point as A dash. Just see, name of this point which is lying over here is A dash. Now let's move on to the second POI. The second POI is lying on the slant generator O7. Just see, this is my slant generator O7. This is my second POI, point of intersection. Now, since this POI lies on the projection of O7, in the top view, I name it second point, it is B. Now, having located this point B on the projection of O7, now I need to take this point upward, vertically upward, so that it will be meeting my front view of this projector, that is O dash 7 dash over here. Just see, I am going to pick this up. The moment I pick this up, I am able to obtain this point B dash over here. So this point B dash has been located on my slant projector O dash and 7 dash, right? But why I have located it into O dash 7 dash? Because point B was located on this projector over here, plan projector O7. So now corresponding point B dash has been located. Now let's work out the third POI. Third POI lies on the slant projector, this one, O6. Now name of this projector point, intersection point will be C, small c. Now I need to project this point C onto front view of this generator over here. So this slant generator is O6. Now the front view of C, that is C dash, will be located on O dash and 6 dash. Just see, this is the line, it is the elevation projection line corresponding to O dash and 6 dash over here. So once I project it upwards, point C, so once you project point C upwards, you see I am going to locate or find out location of the intersection of this vertical projector with this projection in the front view corresponding to the generator, which is O dash and 6 dash. So third point, that is C dash, has also been located. Now let's work out the fourth point. The fourth point of intersection of the cutting plane lies on the generator, that is O5. Just see, this is the slant generator or a slant projector O5. Onto this I have been able to locate fourth point of intersection, which is my point D. Now the front view of this point D will be located on projector, which will be corresponding to O5. And which is this projector in the elevation? This is O dash, please check, O dash and 5 dash, right? So onto this projector, you see I have drawn a vertical projection line. So wherever this vertical projector line which is drawn through point D, which is POI in the top view, so wherever it intersects on the slant projector O dash 5 dash, I obtain the point D dash over here, right? Now next point, point 5, it lies on the, please check, projector O4. It lies on the vertical projector over here, as it is shown in the top view, O4. Now this is the slant projector O4. Name of this point will be E, because this is my fifth point. Now since if I want to move this point upward, you see I am moving this point upward and it should intersect my front projector O dash and 4 dash. But as I see, I am moving this point E, this point will be crossing this O dash 4 dash very easily. So no point of intersection has been observed over there. So this is similar to the situation which we had encountered while we were discussing the projections of the cone. Because any point which is lying on the axis, now we have to work out the relationship between the radius and the height over here. In the first case, what we were given while we were discussing the projections of the cone which was cut by an AIP, we were given the height. So from the height we transferred it onto the 90-degree side and then obtained the radius over here. But now this is the reverse case. Since our cutting plane, that is AVP, is cutting the axis over here, so we know this radius, the radius at which I am able to find this point E. And as we have discussed earlier also, there is a definite relationship between radius and the height. If the cone is being cut on the axis at this radius, the height will be more. If a cone is being cut at this radius, you can see this is the radius, then the height is less. and if the cone is being cut at this position, so the radius is more but the height is less. So this is the relationship. So earlier what we did, we converted height into radius in the earlier situation, but now since the radius is given, what we have to do, we have to look at this particular point from 90-degree angle, that is from this angle 90 degree. So how that will be done, please see. I will keep the compass needle over here at the point O, axis point, and I'll open my compass OE equal to OE because I know the radius. Since I am knowing the radius of this arc, I will be projecting it so that I want to transfer it at a distance of 90 degree over there. I want to look at this cone from 90 degree orientation. So I'll open this compass and then rotate it up to the projector O1. You see, I am going to rotate it up to the projector O1. And once I rotate it up to the projector O1, I will be getting this radius transferred onto this projector, which is very clearly seen in the front view, right? So I obtain this point. Just see, I am going to draw this arc over here. So once I have this radius over here, and because you see this point coincides with the axis, so no you see point of intersection is seen with the help of O dash 4 dash. So what I have to do, I have to start looking at this from this angle 90 degree. So how that is possible, I am going to draw an arc, that is I am going to transfer this radius onto O1, and once I transfer this onto O1 projector, now the vertical projector through this radius will be taken above, and I will be getting the height at which this axis has been cut over here. So just the reverse we had done when our cone was cut by an AIP over there. So there we were given the height, from the height we obtained the radius, we had brought the radius down and then marked this point. So here it is just the vice versa. Here we have the radius available, we have transferred the radius to the 90 degree angle, that is on projector O1. After transferring it onto the projector O1, now I am going to take this upward and it will be met on the projector O dash 1 dash. So this point, and from here if I draw the horizontal projector, I get the height point corresponding to this point E over there. So the front view of the point E has been located over here this way. So this is the procedure for evaluating the height, and as you can see, as I have told, had the radius been smaller, height would have been higher. Had the radius been higher, height would have been smaller. So there is a definitive relationship between this height and the radius of the cone which will be obtained over there after the cutting over there. So this point E we have transferred by rotating it 90 degree, transferring it up onto the projection line O dash 1 dash, and then transferring back to the axis line. So we have obtained the height of this point E dash, that is the POI intersection in the front view has been located. Now the last point, which is located again on the base, so no more POIs are there with the any of the slant generator because no other slant generator has been cut. Now this is the sixth point, point F over here. So now F point lies on the base of this cone, and now we are going to project it upward. So this is point F. So this lies between the base sector 3 to 4. So what are its front views? So 3 dash lies here, 4 dash lies here. So between this 3 dash and 4 dash on the horizontal plane, I am going to get the location of this point F. So let's transfer it. Just see, I am projecting this point F upwards till it meets the base front view projections at the base, that is between 3 dash and 4 dash. So this point F has been located over here. So just see, all the 6 points, they have been located in the front view, and we very well know by now, in case any cylinder is cut or in case any cone is cut, so POIs will be joined with the help of a freehand curve over there. So the freehand curve passing through A dash, B dash, C dash, D dash, E dash and F dash. 6 points we do have. So this is the front view of the rectangular hyperbola, that is the shortened view or the apparent view which has been obtained in sectioned front view. So the name of this view which we have obtained is called, this is the sectioned front view. And since our cutting plane and our sectioned plane, this was inclined to the vertical plane, so the projection obtained on the vertical plane will be the shortened view. So we want to obtain the true shape of this section. You see, we want to obtain true shape of this section. In order to obtain true shape of this section, what we need to do? We need to draw another auxiliary vertical plane AVP parallel to this cutting plane. So we have drawn another AVP x1 y1 which happens to be parallel to this particular cutting plane. And now how many POIs there were located? 6. A, B, C, D, E and F. So through these 6 POIs, I am going to draw projectors onto this AVP, and the projection which will be obtained on AVP, they are called auxiliary elevation. And the auxiliary elevation view which I will be obtaining over here onto this AVP will provide me with the true shape. Now you see, 2 projectors I haven't extended beyond x1 y1 line. Why? Because these 2 projectors points in elevation A dash and F dash, they were lying on the XY reference line. So these 2 projection lines I have only extended up to the x1 y1, whereas for the remaining all the 4 projection lines I need to work out the distances of B dash from xy, C dash from xy, D dash from xy and E dash from xy. So let's start working upon these projections. So the first projection point is A1 dash. So this is the auxiliary elevation. So the distance of all the 6 POIs from the XY reference line in the front view needs to be evaluated. So distance of point A dash from XY, it is 0. So please see, this is the locus line of the projector which is emerging from A. So on the locus line which is emerging from top view point A, so one point A1 dash has been located on the XY x1 y1 reference line because its distance from XY was 0. Now the second point, on the locus line of the second projector, you see, which is emerging from POI B. So this is my second projection line for B. So here B1 dash will be located. So how much is the distance? You see, this is my location of B1 dash. So I am going to measure the distance of B1 dash from the XY reference line. So this distance will be measured. Once I measure this distance, so this distance will be transferred onto this locus of the projection line emerging from POI for corresponding to the plan of point B. Similarly, from point C, third locus line is emerging. So let us work out the distance of point C. This is the distance of point C dash from the XY reference line. Please check. This is the distance of C dash. So this distance will be marked on the projector line which is emerging from POI point C over here. Similarly, for point D, just see, this is the POI locus line which is emerging from point D. So this is fourth locus line corresponding to point D. So this is the distance of point D dash from XY reference line. So the distance of point D dash from the XY reference line is this. I will be measuring this distance and marking it over here. And finally the last point, this is E dash. So this is E dash, and again this is the locus line emerging through POI for E point in the plan. So E1 dash has been marked. And finally F. So no measurement is required because it is F point lies on the horizontal plane. So F point will be marked over here, F1 dash. So having located all these points over here, again a freehand curve has been created and shading has been done at an angle of 45 degree with respect to x1 y1, and this view which is called auxiliary elevation which is obtained on the AVP which happens to be parallel to the cutting plane. So this view provides us with the true shape of this cut section, right? So this way we have discussed in today's lecture how to draw the top view projections, how to draw the front view projections, and how to draw the true shape projections for the cut section using the fundamentals of projections of solids, projections, then section of solids, and then the auxiliary plane method. Now let us complete the uncut portion of the solid which is visible to us in the top view as well as in the front view. So please check, this portion of the solid has been cut by the cutting plane. So here this is the portion of the solid which has been cut by the cutting plane, and this portion has been discarded because this is no longer required. Now we are going to show the top view of this cone as it is visible to us after the cutting has been completed. So after the completion of the cutting, so this portion has been discarded or done away with. So this is the remaining portion of the cone which is available to us or visible to us from the top view. So you can check, this is the remainder portion of the cone which is available with us or visible with us in the top view. Similarly, in the front view, this portion of the cone is visible to us. So we are going to show this thing in the front view as well. So please check, this is the remainder portion of the cone which has not been cut by the cutting plane. So this portion, this is already represented in the front view through this sectional front view, which happens to be the apparent shape of this particular rectangular hyperbola, whereas the remaining portion is visible to us in the front view over here, and this is the true shape of the cut section which is available with us in the auxiliary elevation which has been drawn onto the auxiliary vertical plane. So this is all about the discussion regarding the section of the cone which has been cut by an AVP which is inclined to the vertical plane and perpendicular to the horizontal plane. So we will be continuing with the discussion regarding few more cases of section of solid in our subsequent lectures. So thank you very much. Thanks a lot.